If you have ever disassembled an industrial machine or an electric fan, you will surely come across small steel bearings like this. They may look small, but to create an international standard bearing that can withstand heavy loads and rotate for tens of thousands of hours continuously, behind it is a whole technological chain that is precise to the micron. Today, I, Engineer An, will take you back to the production process of high-quality bearings at a modern factory in China. And you will be surprised to know the strict standards behind something that seems very simple. I am especially impressed with the system that checks the clearance and rotation speed of the bearings using extremely sensitive force sensors. Each one is tested separately, ensuring that there is no deviation of even 0.001 millimeter. However, in my experience, they can completely combine computer vision technology to detect label errors or damaged packaging during the packaging process. Next, we go back to the rough grinding and fine grinding stages. This is an extremely important step to ensure that the bearing surface reaches the standard gloss level. Do you know? With industrial bearings, the surface must have a roughness of Ra below 0.2 to be able to operate durably without causing friction or generating heat. Here, the automatic CNC grinding system with diamond grinding wheels operates continuously, checking the gloss with an optical measuring machine and force sensor. If it exceeds 1 micron, the product is immediately rejected. If I were the designer of this line, I would integrate inline laser measurement technology with real-time AI to analyze and predict the error level immediately during grinding, helping to reduce the possibility of failure by 70% and save on final inspection costs. Now let's go back to what I think is the key to bearing life: heat treatment. A standard bearing must have an international hardness to withstand heavy loads and resist deformation during operation. Here, the steel is heated to over 800 degrees Celsius in a continuous furnace, then immersed in a cold oil bath to harden, and then cooled evenly. This process creates a stable crystalline structure of the steel and increases its wear resistance. I like the way they use a continuous heat treatment furnace. It's very energy efficient. However, if they were to add a cluster-based infrared temperature sensor system, they could detect local temperature errors and make adjustments immediately, reducing cracking or overheating by up to 50%. We move on to the blank machining step, turning round steel bars into the correct size bearing blanks. Here, multi-axis CNC lathes simultaneously machine the inside, outside, and mill the oil holes without rejigging. This helps to minimize errors and increase accuracy. The allowable deviation at this stage is less than 10 microns, 1/10 of a human hair. And if the error is larger, the entire blank is discarded. I recommend switching to a flexible 4-axis milling system. This not only reduces setup time, but also allows the machine to machine many different bearing models without having to change tools frequently. This is a step that I always appreciate for its precision and safety. Steel balls are installed between the two rings, inner and outer, then the clearance is checked. Too tight, the bearing is stuck. Too loose, causing vibration, wear on the equipment. After that, the bearing is ultrasonically cleaned to remove steel dust, then automatically lubricated. This step helps reduce friction, increasing the life of the bearing when operating at high intensity. I appreciate the force sensor system that checks the clearance of each bearing. But if the factory integrates AI to analyze real-time data from this sensor, they can detect abnormalities, predict errors early, and significantly reduce scrap. Looking at the entire production line, I realized that if IoT and AI technology were applied to the entire process, from heat treatment, machining, assembly to inspection, the quality of the bearings could completely meet European standards, while the price would still be extremely competitive. In addition, I am researching a type of nano-lubricant that can create an ultra-thin and durable oil film, increasing the life of the bearing by up to 30%. If this factory applies it, it will certainly become a formidable competitor in the industrial equipment market. You see, a small bearing, but the value it brings to the entire production line is huge. And if in the future, bearings can integrate sensors to self-diagnose errors while operating, the mechanical industry will certainly enter a whole new era. What do you think about this idea? Comment below the video so that you and I can discuss it further. Don't forget to like and subscribe to the channel. I'm Engineer Ayan. See you in the next video.